Is the exoplanet Proxima b the cosmic twin of Earth? Since its discovery, this alien world has been suspected of harboring a tantalizing secret. Not only does the celestial body have Earth-like dimensions, but it also orbits in the habitable zone of its home system. In other words, this means that Proxima b could have liquid water, and thus perhaps even life. To get you started, here's a little quiz question. How many planets are there? Actually 8 or 9. Because we still count Pluto? Well, not quite. Because there is one thing we must not forget. There are countless planetary worlds outside our home system too, orbiting a host star other than the Sun. Expressed in numbers, this means that we now know of 6,911 exoplanets in 4,141 different systems. But the crucial question is whether an Earth 2.0 is ultimately hiding among them. Well, in fact, the chances of this are, at least on paper, not bad at all. The truth is that the almost 7,000 known exoplanets are just the tip of the astronomical iceberg, and experts estimate that there could be up to 50 billion more planets in the Milky Way alone. In view of this, more and more researchers are answering the oldest question of mankind, whether we are really alone in the universe, with a clear no. But is it even possible for us, from our earthly point of view, to catch a glimpse of those extraterrestrial life worlds that are millions of light years away from us? Well, this question is certainly justified, but perhaps, at the end of the day, it is not at all necessary to venture so far into the depths of space to track down the existence of our hidden contemporaries. Because, true to the motto, why look so far afield when the extraterrestrial is so close? It could be that the next alien civilization is slumbering just an astronomical stone's throw away from us. After all, no other exoplanet comes as close to us as Proxima b. Located in the constellation Centaurus and discovered in August 2016, the closest known exoplanet to Earth is just 4.2 light-years away from us. And let's be honest, what is 4.2 light-years anyway? Well, that's a whopping 37.84 trillion kilometers. And with our current propulsion technologies, it would take several millennia to cover this gigantic distance. Fortunately, and this is the good news, humanity has now put itself in the comfortable position of being able to fathom the mysteries of the cosmos without having to delve into the depths of the cosmos itself. And so it happens that we now also know that Proxima b is by no means alone in its orbit around its anonymous host star Proxima Centauri, because it is orbited by at least 2 other planets. But how do you even detect a celestial body that is trillions of kilometers away from us? Are the James Webb telescopes of our time really so powerful that they can directly detect and capture images of alien worlds? Well, not quite. In reality, indirect detection methods have proven to be the most successful for this. This applies in particular to the so-called transit method, in which a planet reveals its existence by changing the brightness of its parent star as it passes in front of it. In the case of Proxima b, however, it was not the transit method, but the radial velocity method that gave us a sensational breakthrough. In simple terms, this detection principle works as follows. A star attracts a planet with its gravity, which is why it orbits it. And conversely, the planet also exerts a tiny gravitational influence on the star, causing it to wobble or stagger ever so slightly. And although this star dance sometimes only covers a few cm, it's enough to tell planetary investigators that our space maps need a new update. Is Proxima b Earth's twin? Now that a planet has been successfully identified, the question naturally arises as to what kind of celestial body we are dealing with. In detail, above all, it's important to clarify whether it's possibly even habitable. But to be included in the list of potentially life-friendly worlds, a basic requirement must first be met. The planet must be within the habitable zone of its system. This means that it orbits its star at a distance that allows the existence of water in a permanently liquid form. And yet, that is not the end of the story by a long shot, because other factors, such as the atmospheric composition of the planet or the radiation of the parent star, can still throw a decisive spanner in the works of the development of life, despite all favorable starting conditions. But what about the case of Proxima b? Well, with an estimated mass of 1.17 Earth masses, it's generally classified as an Earth-like exoplanet. But be careful. The word Earth-like does not make any statement about the potential habitability of a celestial body. It merely describes rocky planets with a solid surface. And while our Earth takes 365 days to orbit the Sun, Proxima b only needs a little over 11 days for one orbit. Consequently, the distance between the exoplanet and its host star is significantly smaller. In detail, the corresponding distance is just 7 million kilometers. And in view of this, one might think that Proxima b is transformed into a scorching hot furnace by the radiation of its host star. But that is not true. While our Sun is a yellow dwarf, Proxima Centauri is a red dwarf that has only about 12% of the mass of our heat and life giver. But the distance and the nature of the host star are not the only points in which the Proxima Centauri system differs significantly from our own. After all, there is still the fact that, according to our data, Proxima b most likely has a locked rotation, and as a result, always turns the same side towards its central star. In view of this, Proxima b is divided into a bitterly cold night side and a significantly hotter day side. But what does this mean for the overarching question of life? Does this sharp division immediately dispel any thoughts of potential habitability? Well, not necessarily, because between the two extreme zones, there could be a narrow strip that ultimately offers conditions conducive to life. Furthermore, the different planetary faces could even have a positive influence on the conditions in this twilight zone. Interestingly, the scientists' simulations have shown that the habitable area could obtain its liquid water supply from the glaciers on the night side. These would melt near the twilight zone, feeding the lakes and rivers. Has Proxima b already produced life? But what temperatures are actually the norm on Proxima b? Well, the experts have calculated an equilibrium temperature of 39 degrees. To clarify, the equilibrium temperature is the temperature that a system reaches on its own after a sufficiently long period of time. However, this does not mean that the equilibrium temperature necessarily corresponds to the surface temperature. If Proxima b has an atmosphere, it can be significantly higher due to the greenhouse effect. Incidentally, our Earth can also tell us a thing or two about this. Without an atmosphere, the equilibrium temperature of our earthly home would be 8 degrees. But let's now turn to the big question. What are the chances that life is possible on Proxima b? Or that it may have already developed there? Well, this question, or more precisely the question of the existence of liquid water, depends on a few parameters that unfortunately have not yet been conclusively clarified. And yet, a simulation that took into account a suitable orbit and favorable atmospheric composition came to the conclusion that the cool wetness on Proxima b could actually slosh back and forth. But the whole truth is that the habitability of the exoplanet continues to be hotly debated among researchers, mainly due to the turbulent activity of its host star. A few years ago, experts from the University of Colorado observed something that eclipsed everything previously known. It has long been known that the Sun repeatedly attracts attention with radiation bursts, so-called flares. But the bottom line was that what the researchers saw flickering on Proxima Centauri was, believe it or not, 100 times stronger than any solar flare documented to date. In fact, the star increased its ultraviolet radiation by a factor of 14,000 within a few seconds. And indeed, the eruptions there are not only significantly more intense than on our Sun, but also much more numerous. Based on this, one could assume that the extreme radiation would destroy the entire atmosphere of Proxima b over time, thus destroying any chance of life. But it's not quite like that. After all, there is also a scenario in which the planet does not lose its gas envelope to space. To do that, it needs a liquid core that forms a stable magnetic field, and thus keeps the dangerous radiation from Proxima Centauri out. This way, the oxygen and water molecules could be kept on the planet. But as an alternative, there is also the theory that Proxima b originally formed at a much greater distance from its host star and was only later captured by it. Furthermore, it's conceivable that there was once 10 times more water on the exoplanet than on Earth. And even if the extreme radiation from the star had already robbed 90% of the water, there would still be enough today for a gigantic ocean covering large parts of the planet's surface. However, due to the locked rotation, the water temperature would only be moderate in the narrow twilight zone. Because on the night side, the water would be permanently frozen, while on the day side it would resemble a boiling pot. And you're welcome to move your Sting trigger finger to the subscribe button now. Just click the thumbs up and subscribe now to never miss another new video from us. We'll see you soon.